Do you use lambdas? Do you have a Java 8 projects in production? Of course. How many of them? Only 1, 2, 3, 4. Okay, great. So, well, are you satisfied with the performance of Java lambdas? No? Yes? Maybe? Let's see. I did some, so to say, benchmarking performance tests to see, well, should we use lambdas or not? Or maybe you should use lambdas in certain situations. So let's analyze the whole situation. So first of all, as you all know, Project Lambda was the biggest change in history of Java programming language and much bigger than the generics that were included to the Java language 2004. So was it worth to wait? Should we, well, wait for something else in Java 9, for example? Let's try to analyze everything. So first of all, Lambda advantages are as follows. It's a paradigm, functional programming paradigm, and of course, it's easier for you to program, to use the whole power of your multi-core processors, and it supports Stream API. It's a great thing because, well, you can do in parallel so many different things. And the question is, are the lambdas faster than the conventional loops? What's your opinion about it? What do you think? Well, let's see. Okay, first of all, this is my hardware equipment. Since I had enough RAM for testing purposes, and the processors is also pretty good, but I needed to, well, establish a good benchmarking environment. So to say, I had to program my own random object generator to be sure that, yeah, I'm getting really measurable results, so to say. Comparing times were, well, the thing that matters the most. And every measurement was performed 10 times just to avoid some, so to say, anomalies. And I've taken the average values to see, well, who wins the game. This is my domain model. I had a person class abstract and I have a programmer class. And person class has a last name, first name, birth date, and the programmer class has his favorite language as an enumeration, start date, and a salary. The most important things in our lives. Okay, so this is my random object generator. So as you can see, I've generated the first name, the last name. It was like something that generates something that, of course, doesn't make sense at all, but it's a good starting point for my benchmarking. And of course, the birth date is something between the, I don't know, 1976 and 1995 and so on, because we have a younger population that starts programming very early. And of course, I generate the programming language as a random value and a start date and a salary and so on. Okay, and after I create my new programmer object, I add this object to my list. And I'm playing with this number of objects class, number of objects constant, which of course can be stretched from 10 to 1,000,000. To see, well, do we need to use lambdas only for 10 objects, or are they better to, well, for environments with 1,000,000 objects? But does it make sense to have a list with 1,000,000 objects? Do you, well, search through your database and fetch the whole list from the server to the client? Well, let's see. We have a big battle between or among many different strategies. One is the for each loop, the other one is the plain iterator, and of course comparator, parallel stream, and of course sequential stream. So let's see who wins the battle. First of all, this is Java 1.4, nothing special. We have iterators, we have, let's say, a single algorithm that finds the youngest programmer among this, well, 10 million or 100,000 objects. Nothing special. We need to use the iterator to go through the whole list, and of course, let's try to find the youngest one. Okay, this is the iterator strategy. For loop, a little bit shorter. You don't need this while next loop, just a for in loop to see, well, who is the younger one, who is the youngest one. Well, the first one is the youngest, and after that, we are using only the sublist to check the other ones. Okay, and now we need to use the comparator strategy just to be sure that, well, if we sort our programmer's list, the first one or the last one will be the youngest one. Do you agree? Yes. Okay. So this is my algorithm, and now the real power of lambdas. Since we don't need any loops, it's everything, so to say, focused to streams, we have a little difference here. A regular stream, sequential stream, so to say, and a parallel stream. And what do you expect? Well, since you have a single method that can say, well, find and get the youngest one. And the same thing with the parallel stream. And the results are here in milliseconds. So who is the best in this case? Which strategy is the best? What do you think? It's everything there. So old guy iterator wins the game, really? Is that possible? Really? Yes, comparator wins. Our rocky guy wins the game. Okay, let's go on. Is that all? Because we are using only 10 objects. Let's increase the number of objects a little bit. And now, 100 objects. Who wins the game? Who wins the battle? For loop, sequential. Sequential is so slow. Well, since we have milliseconds here, well, it seems like you don't have a difference at all. But it's a huge, huge difference between 0.4 and 5.2. Who wins the game? It's a tie, a draw. No one wins the game. Okay, and let's go on. 1,000 objects. The same story. For loop and the old guy iterator are still the winners here. Interesting. So one more draw. Okay, and now 10,000 objects. We have to, well, talk to our comparator to see what's wrong with that. Since you have 10,000 objects, it's a problematic thing because 11.4 milliseconds means, yeah, comparator is losing a battle a little bit. And for loop wins here. As many objects as you can generate, where the for loops uses this simplest, so to say, algorithm without any boilerplate things behind the scenes. But maybe now is the time for our sequential stream and parallel streams, but starting from the 100,000 objects. And now, finally, we are getting something from our, well, lambda streams. Parallel streams is, let's say, prepared his best performance for this large amount of objects, and now we see the results. And comparator, of course, is out of the game. And comparator, of course, wins this, so to say, battle. It's out of the competition. So comparator is out, and parallel stream is winning, in which case? 1 million objects. But, interesting, for loop, here is also a great, so to say, regarding the performance. Parallel streams, 43.1, and for loops, 33.1. With million objects. So should we start measuring our performance with million objects, or we don't need to use these sequential streams at all? What do you think? For loops are, well, simple. They are not so fancy because you need, I don't know, 5, 6, 7, 8, 10 lines of code, and you can do everything with a parallel stream in a single one-liner. So that's why it's up to you. Do you want to keep it simple, stupid, or if you want to use something else to see your strength, to see your, well, to show your muscles? But of course, parallel stream is showing a little bit, well, good performances, but the old ones are also, well, generating equivalent things. Okay, so for loops is still here, which is the better than the sequential and the parallel streams. So if we summarize our results here, as you can see, the differences here are pretty small, and after that, we are getting higher and higher, and of course, here, the, so to say, key point is between 100,000 objects, and 1 million objects. But should we use a list and collections with so many objects, or maybe we should, well, filter the list or something else? Okay, the next one, if you try to find a programmer with the highest salary, so it's very similar. Just we have to start with finding the biggest big decimal object and compare those objects between the whole, well, collection. And of course, you expect that with small number of objects, the old guys, iterators and for loops are almost, well, identical. But between the 10,000 objects and 100,000 objects, they are losing battle a little bit. They need more time to finish their job. And here, parallel stream is finally doing its job. Okay? And now, filtering. What about the filtering? This nice lambda filtering option is going to show, well, some muscles here. If you want to filter a regular array list, first of all, you should start with an iterator, and of course, if it contains a name part, which is generated like a random number, or like a random string, you just add the filtered items into a new list. The same thing with the for loop. Well, nothing else, just a few lines of code are missing, so to say. Okay, and now, what about the lambda approach? Here, you can see that filtering last name contains name, and we should use this terminal operation to collect everything as a result, since it should, so to say, be executed in parallel to get a list of programmers. And now, the only difference between the sequential stream and the parallel stream is to, well, try to see what needs to be compared, or which boilerplate code must be executed to get a final list. Collect as a terminal operation to get a list. So, what do you expect now? Are the conventional, so to say, approaches still the best, or regarding the searching functionalities, something changes? Let's see. The same thing. So, the last one, sequential stream, is slowest one, but after the 10,000 objects, the iterator and the for loops they are starting losing the battle, and the parallel stream is finally paying out its performance. So, as you can see, 10,000, 100,000, and 1 million objects, yeah, it's there. You see the performance boost. But before that, if you have only 10 or 100 objects, which is a pretty often situation, of course, during the everyday programming, so to say, you should be able, well, to decide, do I need lambdas here at all, or should I use something else? Okay, grouping as one more strategy added to this benchmarking. It's a nice thing to have a chance, so to say, to group programmers by its programming language. Like, I want to group every programmer since I've created an enumeration with, let's say, key in this map can be Java, I don't know, C, C++, C#, and JavaScript, and so on. And the value is the list of all programmer objects that can, add some, well, that are added to this list as a result, as a value of this pair key value. Okay, so if you start doing the same thing with the iterator, so first of all, we need to create a map, and after that, we get an iterator. We have to use this while loop, and after that, we just need to ask if this particular key is inside the list, inside the map. Well, we just get this list and add a new programmer, or we have a completely new value, new list, and we are adding a new programmer object to this new list. So we are just creating a new pair of key in a language. This is a string, but the valuable list of programming languages is defined within enumeration. Okay, the same thing with lambdas. And now, first of all, we need to cover this shorter version of iterator, our for loop. The same thing, but without this iterator next. And now the lambdas. Here you can see the power of lambdas. It's so easy to group things because you have, after you create a stream, you just need to call collectors grouping by programmer, and this method reference, our functional paradigm, is related with the primary language, and just group, well, key is the language, value is the list of the programmers, and you are there. So it's a great feature because the code is cleaner, simpler, shorter, but what about the performance? What do you think? Almost the same thing. I've noticed that parallel stream is out of 2 out of 10 measurements. Parallel stream generated something totally, so to say, it blows my mind because I didn't expect that the time needed for parallel stream to group things is like 20 times bigger, but only twice within 10 measurements, 20 times bigger than the other measurements. Suddenly, I'm getting, instead of, I don't know, 70 milliseconds, I got like 2,000 milliseconds. I wasn't sure what was, I thought this was a mistake. No, it happens again. So you cannot predict it. 8 times the measurement was excellent. The results were very good. But 2 out of 10 times, something happened with the parallel stream. So maybe the parallel stream is still not so to say, good to be used in every single situation, but the sequential stream is much more predictable, so to say. So here we are losing battle, but only few tenths of milliseconds is the difference, and after that the sequential stream is faster. But what about the parallel stream? Because the value for the parallel stream was much higher. So I decided to remove the parallel stream from this report because this was too close. If you change the scale to like 800, you cannot see the difference. So I've decided to remove the parallel stream from this chart. So what to conclude? Do you like lambdas, or should we, well, prior to start programming, we should decide what is better for us. Maybe it's cleaner, it's of course shorter, but if someone else is if someone else continue with the work on this project after you, for example, on the same classes, you should decide maybe it's better to use 4 loops and, well, save some milliseconds, or if you decide, well, everything should be done through lambdas, maybe you should ignore this small little difference, and of course, try to get the best out of the lambdas. Well, let's see, maybe in the next release of Java, they will do something about it. They will improve the performance of lambdas, but I think, well, since it's a, so to say, a first release, for Java release with the lambdas, maybe we can expect some, well, updates that can generate better results. With fewer objects, less than 1,000, the conventional older way is more appropriate, and the objects type is also, of course, important. If you compare only strings or big decimal, it's not the same. Strings are, so to say, the most well-known object in Java, object type, okay, but what about the big decimals and local dates? The situation is a little bit different. So lambdas start to show their muscles, of course, with the big decimals more often. And the stream have certain amount of overhead. So you should calculate this when you're planning to implement your solution. But one-liner programming, of course, is fancy. If you, well, if you have like a widescreen monitor, you have one-liner is visible, and that's it. But if you use something that refactors your code and formats your code to be visible within the 160 characters or something else, then you have to split on the dots part to be, well, more readable. Okay, guys, thank you for your attention. If you have any questions, just let me know, but I know the lunch is out there, and I understand if you don't have any questions. Thank you so much.